So in example number 3, looking at the first example, 3a, 42 and 56. What is the greatest common factor between the two numbers? 14 will be the highest. You don't want to take out the 2. Not just the 2 only. Not just the 7. Because 14 will be the biggest. Besides 14, do we have anything in common between the two terms? What about the x? X squared is the lowest, has the lowest exponent. What about the y? Just the y here. If these are the things in common, we will take them out. Once you decide to take out the 14, 42, take out 14, what else do you get? 3 times. And once you take out the x squared from x cubed, you get x. What if you take out the y? Y to the power of 4. So you go one step at a time. Starting with the first term. If we had to take out 14 x squared and y, the number would give us a 3. And then the x cubed, once you take out the x squared, we have x in it. Y to the 5th, once you take it out once, you still end up with y to the 4th. And using the same concept, if I'm to take out 14 from 56, take out the x squared from here, and take out the y from there, this is the only thing we will left with. That means we're done. This is how we take out the GCF. When we're working with algebraic expressions, it doesn't matter if they give us numbers to work with, variables, or even symbols. The idea will still be the same. Samuel, 45 and 10. What is the greatest common factor? 5? Besides 5, what else can you take out, Brian? The triangle? What else can we take out in common? Okay. What about the happy face? Yeah, we can take out the happy face. Once we take out everything in common, we will still be getting a minus. And when we take out the 5 from 45, we are still getting a 9 here. We took out the happy face already. We took out the triangles already. And we took out the k, giving us another k for the first term. Andy, what about the second one? Once we take out the 5, the triangle, the k, and the happy face.
The second
2, yes. We will end up getting a 2 here. So as you can see, when you want to work with factoring, it doesn't have to be numbers only. It could be variables, it could be symbol, or it could be something that looks exactly the same, including brackets. Like the one in example number 4. We have a bracket in common. Here is the first part, and here is the second part. The first part consists of 24 times x squared times x minus 4. These are the three things in the first part. And for the second part, we have 42, x, y, and the same bracket again. When you see anything in common, you can take it out to the front, including brackets. Like in this case, we see x minus 4 from both the first group and the second group. It will be part of your GCF. What about the 24 and the 42? 6? Can it be anything bigger than that? Not quite, yeah. So we will take out the 6. We can take out the 6 from those two numbers. What else can we take out? X and x minus 4. We can take out x from both of them. Can we take out the y? No, we cannot take out the y. But we can take out the x minus 4. If we can take out x minus 4 from both of them, we can then move on to the rest of it. There will be a minus in the middle. That minus came from here. When we take out 6 times from 24, and then from the x, we will end up getting 4x. And for the second group, 42, we take it out, we take out the 6, we took out the x here, the y will be here, and those things will now be gone. And that means after you take out the GCF, we will end up with 6x, x minus 4, or x minus 7, y. When it comes to taking out the GCF and working with brackets, it is important to pay attention to what you see inside the bracket. In the next example, part B, they give us a bracket in the first term and another bracket in the second term. We have 2c minus d and d minus 2c. They swap the order of the two terms inside the bracket. When they decide to switch up the order, what happened to your result? One of them will be negative. And it doesn't matter what numbers you are using. I can go with 11 minus 3 or 3 minus 11. You will still be getting a negative difference between the two. So they are kind of similar, but they are not quite the same example. But if I decide to switch up the order for one of them by taking out the negative, if I can take out the negative from the second one, making the plus here into a minus, we will see something in common. Knowing how we can always switch up the two terms with a minus in the middle by taking out a negative, we can then identify the GCF between the two of them. Bill, how many A's would you take out? From here and there. How many A's are you going to take out from both of them? 2? Yep. A squared has the lowest exponent. So I'm going to take out the a squared from both of them. When we take out the a squared, This will now be gone. What about the b? We can take out the b square, because both of them have at least b squared. What else can we take out again? 2c minus d, yes. We can take out 2c minus d from both of them. And once again, there will be a minus. It came from the above. The minus here will give us a minus there. And if we are to take out these many things from the first group, what else do we get here? What are the leftover? Just A? Yeah. And then when we are to take out the GCF from the second group, only B, we left with B only.